Simon Sinek came up with the golden circle, and he said, every organization knows what they do. Some know how they do it, but very few know why they do it. Hi, my name is Shelat, and today I'll be taking you through the why, how, and what of my intelligent traffic management system.
Traffic congestion is a major problem in most metropolitan cities, and the crux of this problem lies in the traffic management system itself.
Every day on my way to school, I would end up wasting 10 to 15 minutes crossing a four-way junction, where all the lanes would get the same green time despite only 2 of the 4 lanes actually having a need for it. In this everyday frustration, I decided to take this up as a school project and ensure that the red-green time is optimized as per the real traffic densities for the junction next door. The aim of this project is to reduce the fleet time for each motorist by designing a simple, adaptive, cost-effective and approachable AI-based traffic signal. In this project, Raspberry Pi was used along with a basic camera to constantly capture images of the traffic lanes. Canny edge detection was applied on these images using OpenCV to predict the traffic densities. These densities were used as an input to modify the red-green distribution time at the signals in real time. To make this work across all 4 lanes, the individual signals were connected to a ZAMP server, which collects densities from each lane and periodically assigns them with an equivalent red-green time. The impact of such a system can be divided into 2 broad categories: social impact and environmental impact. Based on my tests, I was able to predict that 8 seconds will be saved per junction per vehicle. This means 60 ml of fuel and 400 grams of carbon dioxide will be produced less every time a vehicle passes a junction. Furthermore, as the commuters will be less frustrated, the likeliness of violation of laws will reduce, allowing for police forces to be better deployed at necessary locations. Now let us discuss the sustainability of this innovation. The system is collecting a treasure trove of data of India's driving behavior across a cross-section of driving population and vehicles. Data is a key enabler for any AI-based system, and this can be India's go-to data for various purposes. There are 3 broad stakeholders who will be willing to buy this data: the government, autonomous vehicle manufacturers, and mapping softwares. The government requires data of the traffic pattern to better understand where to construct new roads, bridges, or underpasses. Autonomous vehicle manufacturers require this data for developing autonomous driving algorithms for Indian roads and consumers. This data can be sold to various manufacturers such as Tesla, which are trying to enter the Indian market. And lastly, mapping softwares. Our data would help reduce the reliance on satellites and give them more accurate results to find out the ETAs.
Now that you understood the business model, let me explain the scope of the project. Under the Smart City Initiative, the Government of India has initiated a very ambitious urban development program with a total of 99 cities having qualified for a total planned outlay of 2 lakh crore rupees. One dominant area in this program is intelligent traffic management systems.
In conclusion, while we do understand that a business plan is extremely essential for the sustainability of our project, the main focus of this project was to help the people. The system has also been recognized by the Government of India and the PhD Chamber of Commerce and Industry.